Hi students, good evening. So today I am going to explain you how to determine the transfer function of the given system using block diagram reduction technique. Okay. So ஒரு block diagram reduction technique வச்சு நம்ம overall transfer function of the given system எப்படி கண்டுபிடிக்கலாம். That is the task of our session. Okay. So before solving any block diagram, we supposed to keep in mind the rules of block diagram reduction technique. So six rules are there. First rule is look over any series or cascader systems are available in the given problem. If it is, convert into a single block. And second rule is look over any parallel blocks are present in this given system and reduce into a single block. And the third rule is look over any feedback loop is present in the system and reduce into a single block. And next rule is rule number 4. Is there any effect for the our branch point? We simply called as the takeoff point. If it is any effect, we supposed to shift into after the block or before the block. And similarly, if there is any effect by the block, that is a summing block, we need to shift after the block or before the block. Okay. Always keep in mind, shift your takeoff point or branch point at the right side of the system. Similarly, if we are focusing on summing point, move towards the left side of the system. That is, branch point, we take it at the output side, and summing point, we take over to the input side. So, this is the overall things. And the final is repeat once or until we get a solution C of S by R of S. In this system, you just look over G3, this is summing point, that is the branch point before G1. We need to shift after the G1 also, so that it will shows a closed loop transfer function at G1 and H point. And if we shift the branch point after G1, it is to be included at the G3 side is supposed to include 1 by G1. The 1 by G1 G3 பக்கத்துல வந்து கொண்டுட்டு வந்து சேர்க்கணும். If we combine that, both these two are in G3 and 1 by G1 are in cascade. So for cascade, we simply multiply the two transfer functions. Okay. So if you see move branch point after the block, இது கொண்டுட்டு வரோம் அப்படின்னா what we do is supposed to include 1 by G1 so that these two blocks are in series. Then G1 and H will becomes like a closed loop transfer function. Now we simply add the term G2 plus G3 by G1. That is, let's think what we do, eliminating the feedback part and combining the blocks in cascade. Okay. So if we do like that, the system is looking like this. So G1 by 1 plus G1H, this is due to the negative feedback systems which was present in the previous slide. And next G3 by G1 and G2 are in addition. So G2 plus G3 and by G1. So once if we are doing like this, the G1 by 1 plus G1H and again நம்ம கம்பைன் பண்றேன் இந்த dashed points இருக்கு இல்லையா, these two are in series connection வரும். Then we can simply multiply these two blocks. So combining the blocks in cascade. Okay. So what we get? G1 G2 plus G3 divided by 1 plus G1H. So it just simply denotes the overall transfer function of the given systems. ஒரு சிஸ்டம் கொடுத்துட்டாக்கா அதில் என்னென்ன இன்னர் லூப்ஸ் இருக்கு and what are the possible loops are present in the outer side also we supposed to consider, so that we are getting the transfer function. That means the block is in S domain transfer function. Okay, so that means the main advantages of the transfer function, we can easily analyze the system in S domain. So because we already taken the Laplace transform here, we know the Laplace transform advantages is to convert the time domain into S domain. Okay. So similarly, we go for second problem. In this also, there may be some important aspects which is nothing but splitting the summing point. ஒரு சம்மிங் பாயிண்ட்டை நம்ம பிரிக்கிறதுனால எந்த ஒரு எஃபெக்டும் இந்த ஓவரால் சிஸ்டத்தில் இருக்காது. ஸோ தட் வி கேன் ஏபிள் டு ஸ்பிளிட் தி சம்மிங் பாயிண்ட். இந்த இடத்துல G1 ஆஃப் எஸ்க்கு அடுத்தது பார்த்தீங்கன்னா 3 இன்புட்டும் ஒரு அவுட்புட். அந்த அவுட்புட் G2க்கு இன்புட்டாக போகுது. ஓகே, ஸோ வி ஜஸ்ட் கன்சிடர் திஸ். ஸோ வாட் இஸ் அவர் ஃபர்ஸ்ட் ஸ்டெப்? Splitting the summing point so that it won't affect the system response. Okay, so this is step one, and step two, which is nothing but eliminating the feedback path. After that, after splitting the summing point, we are supposed to convert the closed loop path which is present by means of G2 and H2 இருக்குல்லையா, the G2 H2, this is the closed loop path. So what we'll do, we can simplify G of S by 1 plus G of S into H of S. அந்த ஃபார்மேட்ல நம்ம எழுதிடலாம். So that interchange, that is in this slides, நல்ல if you noticed deeply, the summing point பிளாக்குக்கு அடுத்ததா நான் என்ன பண்றேன், ஷிஃப்ட் பண்றேன். If we are shifting such a blocks after the that is the summing point after the blocks, what will do, H1 பக்கத்துல G1 வந்து நம்ம include பண்ணணும் so that it won't affect our overall systems. Okay, if you see G1 and I include பண்ணிட்டேன், so that what happened, G1 and H1 in a series connections. Now we can interchange the position of summing point also. Summing point interchange பண்றதுனால நம்மளால there is no effect in the system. So I can easily interchange the position of a summing point. So next slide, I can split or interchanges the summing point into different position. So that in the இடத்துல one more important thing is, if there is no block present in this R of S, we can consider that as unity feedback systems. Okay, so if we are doing like this, it will becomes 1 plus G1 of S. Okay, so now these two are in series, so we can simply multiply. We are getting the equation C of S by R of S, which is nothing but G2 of S divided by 1 plus G2 into H2 of S plus G1 of S, G2 of S into H1 of S, whole multiply with 1 plus G1 of S. Okay, so ஒரு block diagram கொடுத்துட்டா நம்ம block diagram reduction rules and அதில் we supposed to think, we supposed to keep in mind, and after that step by step procedure we supposed to determine the overall transfer function of the system. Okay, in some cases instead of G1 and G2 they will give the numbers also, numerical values. So don't confuse with the numbers or numerical value. You simply follow the procedure what we discussed in this problems. Okay, thank you, thanks for watching, and if you are having any doubts, inform me. We again we can discuss some other problems. Thank you.